Look at the wall in front of you and find something red. A book spine, a mug, the corner of a rug. Anything red. You're certain of that color. You'd stake money on it. And yet the thing you're actually experiencing right now, the specific redness happening inside your skull, may be a sensation no other human being has ever had, because color is not in the object, and it is not in the light. It is a decision your brain makes, privately, using a rulebook nobody else can read. That's the answer. Two people never see the same color because color isn't a property of the world at all. It's a construction each brain builds alone, from unequal parts, behind a wall that cannot be opened. But that answer, stated flat like that, is almost useless, because it sounds like a party trick, a bit of philosophy you nod at and forget by dinner. The real problem is stranger, and it starts with a question you can't actually answer about yourself. How would you ever know if your red is my green? You couldn't. We'd both point at the same strawberry, both say red, both stop at the same traffic light. The words would match perfectly. The experience underneath the words could be wildly different, and no test on earth could catch it. So let's take that seriously instead of waving it away. Because most people, when they hear this, assume it's unprovable speculation, a fun idea with nothing behind it. It isn't. The machinery that makes your red starts in the back of your eye, and it is already, measurably, different from mine. Here's the first crack in the floor. Look at the cone cells in your retina, the color receptors packed into the central pit of your eye, a region about 1.5 millimeters wide called the fovea. You have 3 types, tuned to roughly short, medium, and long wavelengths, which most people learn as blue, green, and red. Textbooks draw them in tidy equal thirds. Your actual eye is nothing like the textbook. In 2005, researchers at the University of Rochester, Heidi Hofer and David Williams among them, used adaptive optics, the same mirror warping technology built to unblur telescope images, to photograph the living cone mosaic inside individual human eyes. What they found was not a tidy arrangement. In one person, the long wavelength cones outnumbered the medium ones by roughly 40-1. In another person, with completely normal color vision, that ratio was closer to 1-1. Read that again. 2 people, both passing every color test, both calling the strawberry red, and one of them has 40 times more of a certain receptor than the other. The raw hardware feeding the sensation of red differs between us by an order of magnitude, and here's the part that unsettles the tidy version of the story. Those 2 people saw the world as roughly the same. The brain downstream had quietly rescaled everything to make it work. Which raises the question the rest of this depends on. If the brain can absorb a 40-fold difference in hardware and still produce red, then what exactly is red made of? It's made of comparison. This is the piece almost nobody explains, so let me give you a working picture of it. Your eye does not measure the color of light the way a thermometer measures heat. A single cone cell is, on its own, colorblind. It can't tell you what wavelength hit it. It can only tell you how hard it got hit. A dim red light and a bright orange light can produce the exact same twitch in a single long wavelength cone. That cone has no way to distinguish them. Color doesn't exist yet at that stage. It only appears when your visual system compares the output of one cone type against another, long against medium, then that result against short. Color is the ratio between receptors, not the reading of any one of them. Think of 3 microphones in a room, each with a piece of tape over it, so none can hear clearly on its own. No single microphone can identify the song, but line up how loud the sound is in each one, compare the 3, and the pattern tells you where the music is coming from. Your color vision is that comparison, running continuously, about 100 times a second. Nobody handed you a wavelength. Your brain triangulated one, so why does that make my red unshareable? Because the comparison is calibrated to my particular set of microphones, my particular cone ratios, my particular lens, my particular history, and yours is calibrated to yours. We both arrive at a stable answer called red. But the calculation underneath ran on different equipment with different weightings, and there is no port on the side of the head to export the result and check it against another, which leads somewhere darker than the receptors, because even if our eyes were identical, the light reaching them isn't. Consider your lens, the clear disc behind your pupil that focuses light. It isn't truly clear, it's faintly yellow, and it yellows more with every passing decade, filtering out a little more blue light each year. A person of 70 is looking at the world through a lens that would look distinctly amber if you set it beside a child's. This isn't a defect, it's ordinary aging of the crystalline proteins packed inside the lens, the same proteins that eventually cloud into cataracts. Now think about what that means for the artist Claude Monet, who developed cataracts in his 60s. His paintings from those years turned muddy, reddish-brown, the blues nearly gone, because that's what his own eyes were letting through. After surgery removed the yellowed lens in 1923, he could suddenly see ultraviolet-tinged blues again, and reportedly repainted some of the work in shocking new tones. The world hadn't changed. His filter had, and here's the recognition I'd bet lands for some of you. If you've ever argued with someone about whether a wall is white or cream, and neither of you would budge, you may both have been right. You were each reporting honestly on light that had already been altered before either brain ever touched it. That still leaves the biggest gap unaddressed, though. Everything so far, cone ratios, yellowing lenses, is about the eye. But the eye is a lens and a sensor, and lenses and sensors don't experience anything. The experience happens further in, and that's where the wall gets truly high. Let me name the thing precisely, because philosophers have a word for it, and the word matters. The private, first-person quality of an experience, the specific what it is like of your red, the felt texture of it, rather than its wavelength, is called a quale, plural, qualia. The term was sharpened into its modern form by the philosopher Frank Jackson in 1982, in a thought experiment about a scientist named Mary. Mary knows every physical fact about color. She's the world's leading expert on the neuroscience of color vision, wavelengths, cone ratios, cortical pathways, all of it. But she has lived her entire life in a black and white room, and has never once seen color. The question Jackson asked was simple and brutal. On the day Mary walks out and sees a red rose for the first time, does she learn something new? Almost everyone's gut says yes. Of course she does. She learns what red is like. But if she already knew every physical fact and still learns something, then the felt quality of red is not captured by any physical fact, not by wavelength, not by cone firing, not by any measurement. And if it can't be captured by measurement, it can't be transmitted, compared, or verified. That is the wall. Not a technological limit we'll beat with a better scanner. A limit built into the shape of the problem itself. Now, is that argument airtight? No, and I want to be straight with you rather than sell you certainty. Plenty of serious philosophers think Mary learns nothing genuinely new. They argue she gains a new ability, a new way of representing something she already knew, not a new fact. Daniel Dennett spent much of his career arguing that qualia, defined this strongly, dissolve under inspection, and may not be a coherent idea at all. So I'm not going to tell you the science has proven your red is unknowable. What I'll tell you is that the smartest people who've spent their lives on this haven't been able to close the gap, and that the gap keeps reappearing no matter which direction you approach it from. That's not proof, but it's not nothing. And here's where it stops being abstract and becomes something happening in real skulls right now. Because there are people walking around with a fourth cone type. The condition is called tetrachromacy. Most humans are trichromats, 3 cone types. But the gene for cone pigment sits on the X chromosome, and some women carry a version that produces a fourth cone, tuned to a wavelength between the standard red and green. In principle, a functional tetrachromat could distinguish around 100 million colors, against the roughly 1 million the rest of us manage. A researcher named Gabriele Jordan spent years hunting for a true functional tetrachromat, and in 2010 identified one, a woman in northern England, referred to in the literature as CDA29, who could reliably tell apart color samples that looked identical to everyone else in the lab. Sit with what that means. There is a person for whom certain pairs of objects are obviously unmistakably different colors, and for whom our insistence that they're the same must sound like a room full of people confidently agreeing that 2 different notes are the same sound. She isn't seeing the world wrong, she's seeing more of it, and there is no sentence she could ever say that would let you into that experience. She can tell you the samples differ, she cannot hand you the difference. If that just reframed something about how much of the world your own eyes might be quietly leaving out, and there's a stranger layer still coming, one that isn't about the eye at all. Subscribe now, because that part is a few minutes away, and it's the reason this whole thing is worth your time. So far we've stacked up differences in hardware, different cone counts, different lenses, different numbers of cone types entirely. But you could imagine 2 people with genuinely identical eyes, Twins, say, matched receptor for receptor. Would they finally see the same color? And the answer, maddeningly, is still probably not. Because color doesn't finish forming in the eye. It gets finished in the brain, and the brain finishes it using memory. Here's the physical model for this, and it's the one I'd hold on to if you keep only one. Your brain is not a camera reporting what's in front of it. It's more like a betting operation that has already placed its bets before the light arrives. The technical name is predictive coding, the theory that your visual cortex is constantly generating a guess about what you're about to see, and the incoming signal from your eyes is used mainly to correct the errors in that guess. You don't see the world and then interpret it, you predict the world and then let reality nudge the prediction, which means what you see is built partly from light and partly from expectation. And your expectations were assembled from a lifetime of images no one else has ever seen in exactly your order. You already know this happens because you've felt it. Remember the dress? In February 2015, a washed-out photograph of a striped dress split the internet in half. Some people saw white and gold, others saw blue and black, just as vividly, just as certainly. Same pixels, same screen, same wavelengths of light hitting different retinas, and two populations of people looking at genuinely different colors. What separated them wasn't the eye. It was an unconscious assumption about the lighting in the original photo. People whose brains assumed the dress was in bluish shadow subtracted the blue and saw white and gold. People whose brains assumed warm indoor light subtracted the yellow and saw blue and black. Your brain guessed at the illumination, then quietly edited it out before you ever became aware of a color at all. You didn't choose. You didn't even know a choice had been made on your behalf. That single image did more to prove this point to ordinary people than a century of philosophy managed. Because for once, the private construction of color leaked into public view, and half the room realized the other half had never been seeing what they saw. Which raises a harder question than any so far. If your brain edits out the lighting before you see the color, what else is it editing that never leaks, that no viral photo will ever expose, because everyone you know happens to edit it the same way you do? We may not be able to answer that. But we can look at the one place where the editing rulebook gets written down, and that place is language. Because it turns out the words your culture handed you for color don't just describe what you see, they may shape where you cut the world into pieces. Consider the Himba people of northern Namibia, studied by researchers including Jules Davidoff in the early 2000s. Their language groups color differently than English does. They have a single word, sirandu, covering shades English splits into red, orange, and pink. But they draw a sharp line between two greens that look nearly identical to an English speaker. In testing, Himba participants could pick out the odd square in a ring of green tiles almost instantly when it crossed one of their category boundaries, a difference many English speakers struggled to see at all. And when asked to find a blue square among greens, a distinction trivial for English speakers, some Himba participants were noticeably slower because their language didn't carve blue off from green in the same place. Now, I want to be careful here because this research gets overstated constantly, and I'd rather be honest than dramatic. You'll see it claimed online that the Himba literally cannot see blue, that the color is invisible to them. That's false, and it's the kind of inflated retelling that discredits the real finding. Their eyes work identically to yours. They can see the blue square. They just sort it more slowly, by a fraction of a second, because their attention was trained by their vocabulary to look for different seams in the world. The effect is real, and it's been replicated. It's just smaller and subtler than the viral version, and the honest version is the interesting one. That a word can sharpen a boundary in perception without creating or erasing the underlying sight. Think of it like paths worn across a field of grass. The grass is all there, the whole continuous spectrum, but your language has walked certain routes across it so many times that those routes became trails, and now your attention travels the trails without asking. Where English wore a trail between blue and green, Himba wore one between two greens. Neither of you is seeing wrongly. You're each walking a map you were handed as a child and mistook for the ground itself. So stack it all now, every layer, and feel how tall the wall has gotten. Your cone ratios are yours alone. Your lens has a tint no one else shares, aging on its own schedule. You might have 3 cone types or 4. Your brain finishes every color with a prediction assembled from your private history. And the very words you'd use to compare notes with me have already bent where you draw the lines. At every single stage, Sensor, filter, computation, memory, language. The signal passes through something unrepeatable. The wonder isn't that two people never see the same color. The wonder is that we agree as often as we do. And that agreement, it turns out, is the actual achievement, not the illusion. Here's the honest uncertainty I'll leave standing. We genuinely don't know how much our experiences overlap. Maybe our reds are nearly identical, and all these differences wash out in the end. Maybe they're radically different, and we've simply never noticed because the labels line up. Depending on which philosopher and which neuroscientist you ask, you'll get confident answers in both directions. And the truth is that no one has built the instrument that would settle it, because the thing to be measured lives on the wrong side of the only wall biology never gave us a door through. But something remarkable happens the moment you accept the wall is real. When you and I stand in front of the same sky and both say blue, we are not confirming that we share an experience. We are two sealed rooms, each having done a staggering private computation, arriving at a matching label by a route neither of us can show the other. That's not a failure of communication. It might be the most generous thing a mind ever does, trusting that the word will carry across a gap it can never actually cross. If any layer of this changed how you look at the word blue, hit like. It's the one signal that pushes this in front of the next person who assumed color was simply out there, waiting to be seen. There's one more thing, and it's the part I find hardest to shake. All of this assumes there's a stable you doing the seeing. One consistent observer whose red stays the same red across the years. But your lens is yellowing right now, this year, slightly more than last. The child you were saw bluer skies than you see today, not poetically, physically. So the wall isn't only between you and me. It runs backward through your own life. The you of 40 years ago is another sealed room, and you can no more retrieve that child's exact blue than you can borrow mine. You've been quietly losing colors your whole life and calling it the same sky. Tell me in the comments, has there ever been a color you were certain of, that someone close to you insisted was something else entirely? Who was right? I genuinely want to see how the split falls, because I suspect neither of you was wrong. And if there's someone in your life you've argued with about a color and never resolved it, share this with them tonight. Not to prove you were right, but because you finally have the answer, and it's that you both were. You have never once seen the world. You've only ever seen the room where your brain keeps its version of it, and the door has always been locked from the inside.